In today's lesson, we are going to be looking at collecting and organizing data. So, some definitions. Types of data. Primary data is data that you have collected yourselves, and secondary data is data that someone else has collected but you are using. So in this lesson today, we went through, or we're going to go through, and collect data ourselves. I've already pre-collected it, or I've taken the data that a class has already collected. So we are still going to be using primary data. Secondary data means someone else collected it. So if you look at Stats Canada, that would be an example of that. Because they've collected the data, you're just going to use it. It could also be something like any sports websites or things like that where they've already collected the data and you're just taking it. So again, any data that you did not collect yourself physically is considered secondary data. As well, when we're collecting and organizing data, outliers may be something that we come across, and outliers are an extreme value in a data set that is separated from the main body of the data. And now what we mean by separated, we don't mean literally it's just far apart. It could be far apart, but we want to try to be careful of what we're talking about. So in this case, the main thing when we mean by separated from the main body of data means it doesn't follow the pattern of the other values in the data set. It may be separated, which is okay based off of what we're looking at. And we'll see some examples in what we see today. So the main thing today, or where we got our data from, we were looking at arm span. So if you spread your arms out, what is that distance from one end of your fingertips to the other versus the height? So we're trying to see, is there a relationship between your arm span and your height? So we took measurements and we've copied them down into the charts. So I've gone through and I've rewritten them out here. I've removed all identifying information or just all names that we had. So here we have the height and the arm span of the class. And then we have one extra, or one more down below. And so what we did was we took this data and we plotted it on a scatter plot. Right? So each value here is two coordinates of a point, right? Then x and a y value. We talked about before when we're dealing with two variable data, which is this case here, we have two attributes per subject. So in this case, one subject was one student, and we have two attributes collected for them. So for each student, we have the height and the arm span. Those together make a point. And when we graph it, we should get something that appears like this. So this is our graph of the data of the height versus arm span. So each dot here represents an individual student, and it has two attributes associated with it. Next, what we wanted to do was analyze the data. Right? So looking at this scatter plot, do we notice a pattern and describe what you see? So you should see a pattern in this case. So we should be first off, yes. Yes, we do see a pattern. And what do we see? Well, looking at it, we should see that as the height increases, so does the arm span. So that is the pattern that we should be seeing. So as the height increases, so does the arm span. Now, if that's the case, then the vice versa would also be true. As the height decreases, so does the arm span. We don't need to represent both. By saying that as the height increases, the arm span decreases, we'd be implying the same thing on the other side, that the reverse is true as well. 2 asks, are there any outliers in your data? If so, describe what information the outlier is giving you. So if we look at this, an outlier is something that is away from the main body and something that doesn't fit the trend. Now you might say that this person here is an outlier, but I would argue that they fit the trend. It may just be that based on the data we've collected, which is relatively small, right? It's not a relatively large class. It's not a large body of data, so I would say it is a relatively small sample size. We may have more data points that fit in this gap here if we had a larger sample size. So I don't like to say that if it's away from the main body, it's considered an outlier. I like to focus more on, does it follow the trend? And right now, if we look at this, the trend is that as the height increases, so does the arm span. So we'll look at this in a future note, but a good idea might be to draw a line of best fit of some sort. So I'm going to draw a line of best fit right now. I'm trying to go through as many points as possible or have it as close to as many points as possible while still representing the trend of data or how the height and arm span change. Now looking at this, now it might be a bit easier to find some values that don't really fit the trend. Now again, we just drew this by hand, so it may not be the most accurate, but we still should have a good idea. So which points seem like they don't fit the trend? I would say, for example, these 2 points definitely look like outliers because they're far away from our line. They're far away from the trend that we're seeing. You may pick out 1 or 2 more, maybe some of the ones that are below, but right now I would say that these 2 are outliers. Now again, this may change depending on how you drew your line of best fit. So if you drew it a little bit differently and you had a few other points that maybe were outliers, that's okay. We will look at in a future lesson how to accurately do it or to create our line of best fit. Really, we're just using technology because that's the most accurate way that we can do it. So we do see some outliers. We've labeled them. What information are the outliers giving us? So what information are these outliers telling us about the individuals? Well, at their specific height, it's saying that their arm span is greater than what it should be. So arm span is, say, larger, or we might say longer than what is, we'll say, not what it should be, but we'll say what is expected. So based on our data, what is expected, the arm span of these individuals is larger or longer than what we would expect based off the other values that we found. Now again, because it's a line that we just kind of drew, I wouldn't say so much that any point off the line is considered an outlier. You want ones that are drastically away. Right, and I would say that these 2 are the 2 that are drastically away. Next, let's choose a height that is not recorded on the chart, and approximately what arm span would you expect this person to have? So we as a group picked 200. So if we had an arm span of 200 or a height of 200 centimeters, if we were 2 meters tall, what would we predict our arm span to be? So this is where a line of best fit becomes helpful, because if we were to imagine that it would continue this trend, we would expect it to be somewhere maybe around there, maybe a little bit higher. That's where we would expect our point to be for someone that is 2 meters tall. So let's call this prediction. So that's our prediction that we're making. It was 200 meters tall or 200 centimeters tall. What would we predict the arm span to be? Well, again, it's a hypothetical because we are kind of off the grid here, but because we're going up by tens, maybe this is about 205 maybe. So we would predict that someone that had a height of 2 meters or 200 centimeters would have an arm span of 205 centimeters. So we had 200 and 205 as our point. So again, 200 meters, or sorry, not 200 meters, 200 centimeters height would have an arm span of 205 centimeters. And again, this is all predictions. So it doesn't necessarily mean it's right or wrong. It's just a prediction that we're making based off of the data we've collected. So again, the main thing from this is just understanding just how to collect data, the different types of data, and then just plotting it on a scatter plot, which we can then use to look for patterns, make predictions, and identify any outliers.